When we get our hands on a new AI system, what's the first thing we do? We want to see it work, right? We look for success. But what if that instinct is totally backward? What if the real key to trusting AI isn't seeing it succeed, but watching it fail?
All right, so let's dig into that. I mean, it's a completely human thing to do. You get a new tool, you give it a couple of easy tasks, and you see what it does.
And if the outputs look pretty good, they seem plausible, they're helpful, our confidence just shoots through the roof. We're immediately thinking, awesome, this thing is great. And then we start depending on it, weaving it into how we work. And that, right there, that's exactly where the trouble starts.
So that brings us to the big question for this explainer. What if that early confidence, that little dopamine hit of, hey, it works, is actually the biggest risk of all? Because that feeling can hide some really deep problems and set us up for a huge fall later on.
So let's talk about this first section, the trap of early success. We really have to unpack why those first few outputs that look so good can actually be, well, a total illusion.
Okay, so what we're looking at here is this huge gap between perception and reality. What we see is a system that seems smart, helpful, totally plausible. But what's actually happening? Well, the system is basically playing on easy mode. We're tossing it softballs and a perfect environment. Of course it's going to look good. And this creates something called a false sense of reliability. It's a mental trap we fall into. We start believing the system is trustworthy, but here's the kicker. We haven't even begun to understand its limits. We have no idea what its boundaries are or all the different ways it can and absolutely will mess up. This chart just nails it. This is the trust gap. Look at that. Our trust in the system goes way, way up, but our actual understanding of it, its weak spots, where it's going to break, that stays dangerously low. And that massive gap, that's a breeding ground for disaster. And here's why this is so critical. Once that trust is established, even if it's not earned, we stop second-guessing the AI. An error pops up, and what do? We don't catch it, we just accept it. And that little error starts to spread, it gets baked into other decisions, and suddenly it's a massive problem that's way harder to track down and fix. This is where we need a total mindset shift. This idea that failure is not a defect to hide. We've got to stop thinking of failure as some dirty secrets or a bug we need to patch and pretend never happened. No, failure is information. It's valuable data. Which brings us right into our second section, the revelation. The whole idea here is that failure actually reveals the truth. It's the only way we can actually see the boundaries of a system, to figure out where the map ends. Think about it. When we purposefully push a system until it breaks, we learn so much. We find the exact stress points where its assumptions just fall apart. We see where we absolutely need to add a safety control or a human check. We even learn how it puts pressure on our judgment. And maybe most importantly, we figure out what we have to log so we can hit undo when things inevitably go sideways. And this leads to a wild paradox, doesn't it? A system that looks perfect in a lab, that never fails during testing, that's actually the most dangerous system you can have. Why? Because it just means its flaws are invisible. And they're going to show up for the first time, out of the blue, in the real world, where it really, really counts. Okay, so what do we do about all this? Well, we need a whole new framework. One that's not built on gut feelings or those misleading first impressions. It has to be built on cold, hard evidence. And it's a really deliberate process. Step one, you actively try to break the system. You throw edge cases at it, give it confusing prompts right from the start. Step two, you take those failures and use them to figure out exactly what guardrails you need, what needs to be logged or reversed. Step three, you test your own team. Can a human actually see when the AI messes up and do something about it? And then, and only then, do you start to grant trust. Not because it feels right, but because you have the evidence to back it up. Because if you skip this, if you don't intentionally expose the system to failure, any trust you have is just blind faith. And letting blind faith run important processes, that's not just risky, that's the definition of automation risk. You're not engineering a solution anymore, you're just gambling. All right, it's super important to be clear about what this framework is and what it isn't, because it's really easy to get the wrong idea here. So to be clear, what this explainer does is give teams a roadmap for building trust safely. It demands that you show your work. It demands evidence. What it does not do is say don't experiment or your system has to be perfect. That's not the point at all. The goal isn't to have zero failures. The goal is to know your failures, to understand them, so they don't bite you when you least expect it.
So really, it all boils down to these three simple principles. When you're building trust in AI, you have to be slow. It has to be evidence-based, and, this is crucial, it has to be reversible. You always need an undo button.
So let's leave it with this final thought. Failure is not the enemy. Unexamined trust is. We shouldn't be afraid of seeing our systems fail. The thing we should really be scared of is trusting a system when we haven't done the work to see where and how it breaks.